Okay, these are notes 1.3 and deal with different kinds of things with linear functions. So we'll start off with that. Suppose by noon 2 inches of rain had fallen, and rain continued to fall at a rate of 1/2 inch per hour. So we think about kind of the graph for this. At noon, we'll say this is, at noon there were 2 inches, 1, 2, and every hour, so 1 hour, 2 hours, 3 hours later, it increases by 1/2. So it goes up 1/2, up 1/2 for every hour, up 1/2 every hour. So we have this function, f of x. X is the number of hours. Y is our how much rain has fallen. So it is, remember, y equals mx plus b. Remember that from Algebra 1? So our y-intercept, our b, is at 2, and our slope is how much it increases for every hour. So up 1/2 over 1. So our equation would be 1/2 x, 1/2 for every hour, plus 2. So if we think about f of 3, okay, 3 is our x value. So at 3, what would be that y value? How much rain would there be? Well, it would be 1/2 for every one of those hours, plus the initial 2. So that's 1.5 plus 2 equals 3.5 inches of rain that happened there. Okay. Linear function. Okay, we kind of went over this already. A slope-intercept form is y is equal to mx plus b. And if you remember, the m is our slope, and the b is the y-intercept. So if you look at this graph here, well, last 1.2 we kind of graphed one by picking any x values and plugging them in and so forth. But if we want to use this idea here, our y-intercept is at 3, and our slope is 1/2. So remember, slope is the rise over the run. So it's going to rise 1 and run 2. It's going to rise 1 and run 2. It's going to rise 1 and run 2. And you get your graph there. Okay. Next thing, we're going to talk about our x and y intercepts. So if you think about a graph here, if I just draw any kind of line here, this here is my x-intercept. And you notice that x-intercept has a different x value, but the y is a 0. And if you think about here, the y-intercept has a x of 0 and a y of some number. Okay. So to find any x-intercept, the y is always going to be 0. And to find the y-intercept, the x is always going to be 0. So if I plug 0 in for the y, 2 times 0 is 0. So I'm left with just 3x equals 12. Divide gives you x equals 4. So I have the point 4, 0 is my x-intercept. Okay, to find my y-intercept, I set the x equal to 0. So 3 times 0 is 0. So I'm left with negative 2y equals 12. Divide by negative 2, I get negative 6. So that point is 0, negative 6 there. So if I know that this is my x-intercept, that's my y-intercept, that gives me my line. Okay. You give this one, pause the video and give it a try. Okay, so you're back. And remember the x-intercept and the y-intercept. Okay, I know the y-intercept already because that's at 5, right? So 1, 2, 3, 4, 5. Okay, so we know that's the y-intercept there. And the x-intercept, I set 0 in for the y, so I have the equation 0 is equal to negative 2x plus 5. Subtract your 5 over, divide by negative 2, you get 5 halves. 5 halves is the same as 2.5, so right there would be the x-intercept. So there we have our line. Okay, the 0 of a function. Now if you remember back in Algebra 2, the 0 is the same thing as the root, or the x-intercept, or the solution to the problem. Okay, so if I want to find the 0 of this, I want to know where my y, what x gives me the y of 0. Very similar to what we just did over there. So you subtract the 5 over and divide by negative 2, gives you 2.5, which is the same thing as what we said as the x-intercept, right? So x-intercept is there at 2.5. Okay. Once again, here to find the 0 is where my x-intercept, where my y is a 0. So I have 3x minus 2 times 0. Basically, that cancels out. 3x equals 12, therefore x equals 4. And you can see over here on this one right here, those are where my x equals 4. My x-intercept there is the 0, or the solution to what I'm looking for there. Okay, number 5. A 100-gallon water tank is being drained at a rate of 5 gallons per minute. So we have 100 gallons in there. Every minute, 5 gallons is being drained out of it. Okay, so our formula. Okay, so let's get a little graph of it here too. I know it starts with how much? 100 gallons, and it's going down at 5 gallons per minute. So this is the number of gallons, there's our minutes. Down 5 gallons over 1 minute, down 5 gallons over 1 minute. Okay, so I know my f of x is going to equal, now it's down 5, so it's losing 5, so negative 5x plus 100, starting at 100 with my y-intercept. Okay, after 6 minutes, basically what I want to find there is f of 6. So that's negative 5 times 6 plus 100, so negative 30 plus 100, there would be 70 gallons left. Okay, x and y intercepts for this. Well, I know the y-intercept, and that one's easy. The y-intercept is there at 100, so 0, 100. That means at 0 minutes, there were 100 gallons in there. The x-intercept, remember, for the x-intercept, I set the y equal to 0. So 0 is equal to, this is f of x, same thing as y, negative 5x plus 100, and I solve that, subtract the 100 over, divide by negative 5, and I get 20. So my x-intercept out here would be at 20, so it would be the point 20, 0, which means after 20 minutes, we have 0 gallons, so it's completely drained at 20 minutes. Okay. Number 6. Average cost of tuition and fees at a private college was this much, and by 2008 it had increased to this much. If it increases linearly, which means the same amount every time with a certain slope, what was the average rate of change? What was the average slope? Okay, so if you remember slope, we use the letter m, and it's the change in y over the change in the x, which you also saw this formula in the past. y2 minus y1 over x2 minus x1. Okay, so for this particular problem, it changed. Okay, so the amount of money that's changed over the amount of years that's changed. Okay, so it's the 25,143 minus 14,709 over the 2 years. It was 2008 to 1998. Gives you a change of 10,434 over 10 years. Simplified gives you $1,043.40 per year. Okay, that's our slope, that's our rate of change. So, another problem, if you want to find slope, back in pre-algebra you did this. Remember, it's the y minus the y over the x minus the x. Side note here, would it be okay to do 3 minus negative 1 over negative 5 minus 2? Would those give us the same thing? They will. The negative 4 over 7 is this one, and this is 4 over negative 7. Notice the same thing there. Try the next one yourself. Pause it. Okay, welcome back. And y minus y on the top, x minus x on the bottom gives you positive 4/7 in this problem. Okay, number 8. Graph the line through this point. So I know it's going to go through this point, 2, 1, with a slope of negative 2/3. That means that I know it's going to go down 2 and over 3. Or, what I did was this, negative 2 over 3, down 2 over 3. Would 2 over negative 3 be the same thing? Yep. So I can go positive 2 and then negative 3. Notice it gives me the same graph, same slope. Do not do negative 2 over negative 3. That's not the same thing. Okay. X equals 2. So here's x equals 2. And if I draw a line where all my points, so if I have, all my x's are 2's, my y's can change, I have this line right there. If you remember what the slope is for that, that is undefined. Okay, and y equals 3, there's y3, and on this line right here, every single y, the x's change, but the y is going to be 3 every single time. Remember that slope is 0. The rise is 0 even though it runs, so it's 0 over infinity basically, which is 0. This one here, the rise, it rises infinity and runs 0, and you can't divide by 0, so that's why it's undefined there. Okay, number 10, I'm going to graph this in slope-intercept form, and just remember that we did a lot of this in Algebra 1, I think. The y-intercept is 3, slope is 2, so 2 over 1, rise is 2, and over 1. You can also go to negative 2 and negative 1 to give you that same positive slope there. Start at 3, y-intercept of 3, negative 2, so move down 2 over 1, or I could also go 2 over negative 1, which is up 2 and negative 1, and it gives you that line there. Negative 3, y-intercept, slope goes down to positive 1, or positive 2, negative 1. Gives you your graph there. Okay. In 2008, there were approximately 42 million people worldwide living with HIV and AIDS. At the time, the infection rate was that many people per year. Okay. So whenever you see this people per year, that probably means it's your slope. Okay. So it says after 2008. So we're going to make x equals 0 2008. So if you're looking at a graph, right here 0 is 2008. So 1 would be 2009, 2 would be 2010, etc. So in 2008, there were 42 million, and your y-intercept, and it increases at 5.1 million per year. So up 5 million over 1, up 5 million over 1. Okay, and you get your graph there. So the model, number of infections would equal 5.1x plus 42. We're just going to say this is all a million, so we won't put the extra numbers and stuff there. Okay. So 2011. So if this is 0 is 2008, 9, 10, 11. So we're looking for f of 3. Okay. So it would be 5.1 times 3 plus 42 gives you 57.3 million people worldwide that would be infected. Hopefully that rate's been coming down. I should check that out and let you know, or you can check it out. It'd be nice if the rate of infection is not 5 million people anymore. Next one, write the equation in slope-intercept form. Slope-intercept, remember, is y is equal to mx plus b. So we have to find the y-intercept, which is negative 2. And the slope, this one goes up 2 and over 3. So we have y is equal to up 2 over 3x, and y-intercept negative 2. Try these yourself, and then unpause. So here we have our slope goes up 1, left 3, so negative 3. So up 1 and left 3, x, and then the y-intercept is negative 1. And this one here is y is equal to, it goes up 1, 2, 3, and over 1, 2, 3. And 3 divided by 3 is 1x. You could just put x to it, doesn't have to be 1x. And then minus 2 for your y-intercept. And that's all 1.3. Give the homework a try.